All right, so today we are going to be learning how to solve quadratic equations using square roots and completing the square. That's our goal for today. So completing the square means that we're going to start with a binomial in the form x squared plus bx, and we're going to turn it into a perfect square trinomial. Well, what is a perfect square trinomial? We're going to learn that right here. So we're trying to factor x squared plus 2x plus 1. So here's the way we do it. We're going to set up our double parentheses, and we look here first. We know x times x is x squared. Now we look here. We need numbers that multiply to be 1 and add to be 2. What are those numbers that multiply to be 1 and add to be 2? 1 and 1. And in fact, I need them to add to be a positive 2. So what do I want the signs to be? Plus on both. So another way of writing this, if these two are exactly the same, is to say x plus 1 quantity squared. That's the best way of writing that. So the way this factors down is into x plus 1 quantity squared. All right, let's look at the next one. Set up your double parentheses, x and x. We need numbers that multiply to be 4 and add to be 4. What are the numbers? 2 and 2. And in fact, we want them to add to give us a positive 4x on the outers and inners. So what do we want those signs to be? Plus and plus. So a better way of writing that is as the binomial x plus 2 quantity squared. You should see a pattern developing here. Do you think you know how this would factor? Maybe not yet. I want you to look at some pattern here. What is half of 2? And then what's 1 squared? 1. So I want you to look at B. Actually, I want you, let's do it this way. Let's say take half of B and square it. If that equals C, then it is what we call a perfect square trinomial. So if half of B squared is equal to C, then this is what's going to happen. It's going to factor into x plus or minus the square root of C quantity squared. All right. So if I can take half of B and square it, and that equals C, then that trinomial is going to factor down into x plus or minus the square root of C quantity squared. What do I mean by that? All right. Can I move over a little bit? Look at this. What's half of 2? Square it. 1. So that did work, right? So now the way this, I can go directly from here to here is I know that it's going to have to be an x. Whatever this first sign is, that's what this sign is in here. And then what's the square root of 1? 1. Okay, look at this one. This has to be an x. We use the first sign, and then what's the square root of that C value? 2, right? And so we end up with this, x plus 2 squared. All right, let's do it slowly again, just so people get the hang of it. Let's factor this the old way. X and x, what are numbers that multiply to be 9 and add to be 6? 3 and 3. And in fact, I need them to add to be a negative 6. So what do I want the signs to be? Minus and minus. Now we're going to use the shortcut way. So if I take half of B, I get 3. And I square it, I get 9. So that's going to have to factor down into x, use the first sign, take the square root of 9, quantity squared. See what I mean? How that can be a faster way of doing it? Let's check this one. What's half of 8? Square it. 16. So can you go directly now to this quantity squared? What is it? X minus 4 squared. So we use the x, we use the first sign, and we use the square root. So this is equal to that. Can you think the other direction? Can you think what would this have been originally as a trinomial? If you're not ready for that, we can just write it out twice. So we do x times x is x squared. What do I get on the outers and inners together? 10x. And the last times the last. Doesn't that make sense? If we take half of this and square it, we get 25. And see how that was x plus 5 squared? Looking at patterns, guys. Anybody think they can do this one? What do you think, Hayden?
X squared minus X squared.
Nice. He's right. If you don't believe it, you can write it out and do it. But that's correct. Explain how you knew that.
I knew that 6 times 2, 12. So 6 squared, 30.
Right. And we keep the sign, right? Whatever that sign is, that's what that first sign is. That sign and that sign match. This is always going to be a plus. All right, guys. So why in the world do we care about that? Well, it's going to allow us to do a problem like number 1 down here. Because now I should be able to look at this and immediately know how I can solve this problem. How would this factor down into a binomial squared? How's that factor down into a binomial squared? X plus 2, quantity squared, right? Equals 7. So now I look at this and I say, okay, I can solve this. This is just like what we did in section 3.1. We're going to take the square root and take the square root. So we have x plus 2 equals plus or minus radical 7. Now what do we do? Subtract the 2, and we have 2 solutions. We have x equals, always put this number first, put the negative 2 first. And then with the negative 2, we're either going to add or subtract radical 7. And those are going to be the solutions. Okay? Now, if this had been equal to 0, I would have just wanted to try straight factoring. But it's not equal to 0, it's equal to a number. So then I could test this. Are there numbers? If I take half of this and square it, is it equal to that? Yes. That's what allowed us to do it this way, right? Let's look over here. Can we do this one with square roots? What's half of 10 squared? 25. So I can do this with square roots then. Try this one on your own. I'll be working it slowly up here. See if you can get it. Did you get it? What kind of solution is this? You can say 2 different things and I'll say you're right. They can either be called what? Complex, or you can even just call it imaginary, right? Okay. What else do we know about that? Well, let's do that. Okay, come back here now. Find the value of c that makes this expression a perfect squared trinomial. Then write the expression as the square of a binomial. Well, all we have to do is look at b. We take half of b and we square it. So what's half of 14? Square it. Okay, so now we're going to have y squared minus 14y, and we just said c is going to be 49 for that problem, so plus 49. And now can you guys factor that? Just write it down, what you think it would be factored. Vanessa, what do you think? Good. Did you guys get it? Okay. Let's do number 4. We have to take half of 8 and square it. What's that going to give us? 16 is for C. And now factor it. Caleb, what'd you put?
X minus 4 squared.
Good. And the best way to read this is the x minus 4 quantity squared, because we want the whole thing squared. All right, a little bit different. We have to take half of 7. When you take half of an odd number, I don't want you to put 3.5, 3.5. I want you to leave, when you take half of 7, call it 7/2. Because when we square it, it's pretty easy to square it now. You just square this and you square that. So what do you get if you square each one of those? Square the top and square the bottom. What's C going to be? 49 over 4. So this is now y squared plus 7y plus 49 over 4. And now we can just use our pattern. We do the variable, the first sign, and then what's the square root of this? We just did it. What was it? 7 over 2. Quantity squared. So it's no big deal. If we have if we have an odd b value, no problem. We just write it like that and square it. All right, let's come down here. This equation is set equal to 0. The first thing I always want to check is if I can factor this. Are there numbers that multiply to be 2 and subtract to be 6? No. That means I have to use a different method. The method I'm going to use is completing the square. So I have r squared minus 6r. I have to get this 2 over on the other side. So the first thing we're going to do is move C to the right. Move C to right. Okay, so I have to move it to the right side. So I'm going to add 2 here and add 2 here. We're also going to leave a space here. We're going to leave a space here because we're going to complete the square. So now we're going to take half of B, square it, add to both sides. And then finish the problem. So we always move the C value to the right. We're going to take half of B, square it, SQ is square it, add that to both sides, and then we finish the problem. All right, so what is half of negative 6? Square it. So I'm going to add 9 to the left side, and I'm going to add 9 to the right side. If you start missing these problems, it's probably because you forget to add that to the right side. But whatever we do to one side of the equation, we must do to the other side of the equation to keep it equivalent. All right, now we just finished the problem. What's another name for this? Look, if I take half of this and square it, don't I get 9? So now I do the square root. Right, the first sign and the square root equals 11. And now we take the square root of the left side and the square root of the right side. So I'm going to have r minus 3 equals plus or minus radical 11. And how do we finish that? Just do what? Add 3 over. I don't have much space, so I'm just going to do that without showing it. When we run out of space, we just think ahead. We added 3 over there. So we have 3 positive and then plus or minus the radical 11. Questions there? Okay. Do you remember what I do first? Add 4. So if I add 4, it's going to become positive 4 over here. Can you tell me what I'm going to add to both sides? Do you know it, Isabel? Good. We take half of 8 is 4, squared is 16. I add 16 on the left, so I also have to add it to the right. See if you can finish this problem. If you get stuck, just look up here, but try it on your own. Did anybody get it right? Good. What questions do you have, guys? Did you know how to simplify radical 20 okay? 4 times 5, 2 radical 5? All right, good work. Okay, let's go down to number 8. We're going to have to deal with a fraction this time. Here's a common mistake I see. People are like, oh, this is already factored. So I'm just going to say y equals 3/4 and y plus 1 equals 3/4. You can't do that. If this had been equal to 0, then you could. But if it's equal to a number, you cannot do that. You have to multiply this out. So we're going to have y squared plus 1y equals 3/4. Leave a little space in there because we have to complete the square. What do I do with this b value? I have to take what? Take half of it. So what's half of 1? 1/2. Square it. What's 1/2 squared? So I have to add 1/4 on the left and 1/4 on the right. All right, so now this has to be a perfect square trinomial because I just created it to be one. So here's how we do it, guys. We do the square root of this. We do the first sign. And do you know the square root of 1/4? 1/2. Quantity squared. Now we have to figure out what's 3/4 plus 1/4. 1. And so now I can take the square root on the left and the square root on the right. So we have y plus 1/2 equals plus or minus what? What's the square root of 1? Just 1. So to finish this, to get y by itself, I just have to subtract a half. Well, what I really have then is I have positive 1 minus 1/2, and I have negative 1 minus 1/2. See how I have plus or minus there? So I have positive 1 minus a half and negative 1 minus a half. Do you guys know what 1 minus a half is? What is it? 1/2. Do you know what negative 1 minus 1/2 is? Negative 1 1/2. or -3/2. So those are the two answers we get. You could say -3/2, -1.5, -1.5, anything equivalent. All right, guys, last one we're going to do here. Can I just set 3x equal to this and this equal to this? Yes or no? No, because it's not equal to 0. So I'm going to have to go ahead and distribute this. I'm going to leave the C on the right because I want it on the right anyway. Well, here's something I haven't mentioned, guys. In order to complete the square, you have to have a 1 as a coefficient in front of x squared. So what am I going to have to do before I can complete the square? Divide every term by 6. This divide by 6. This divide by 6. This divide by 6. Everything has to get divided by 6. Oops, I almost forgot. I just said make sure you divide everything by 6. Did you see I almost put -24 there? I have to divide it by 6. Now, I might want to complete the square, but let's think ahead. What if I brought this back over here and got this set equal to 0? What would it become if I took that back over there? +4. I can always take it back over if I need to, but I'm thinking ahead. Are there numbers that multiply to be 4 and that add to be 5? I'm not going to complete the square if I can factor it. There are numbers that multiply to be 4 and add to be 5. So I'm just going to factor this. I'm not going to use completing the square unless I have to. My poor first bell, they were really tired and I didn't notice that we could factor it. So we went through and completed the square. What do you have to do? Take half of 5. What do you get? 5/2, square it, 25/4. You see how complicated that would get that way? We did it, but this is so much easier by noticing that. So x and x, 4 and 1, plus and plus, what are our solutions? Okay, so you can do complete the square and you'll get the right answer, but why not check to see if it can factor first? Okay, questions on that? All right, I want you to look down at the bottom. There are 3 problems. They kind of increase in difficulty as you go. If you're doing pretty well with this, try number 12. If you need something a little easier, try number 11. Number 10 is the easiest. Choose one to do. I'm going to work all 3 and you can check your answer. Okay? Go. Hopefully you were able to get at least one of those correct. What questions do you have? Did anyone think this could factor? Because at first I thought it was going to factor. But they're numbers that multiply to be 3 or 3 and 1. They would have to add to be 2. 3 and 1 add to be 4. So I couldn't factor it. So that's why I had to use completing the square. And I actually got two complex solutions on that because of the eyes. Okay, any question? All right, guys. So you'll have a worksheet to do for homework.